Building a permanent masonry shelter deep in an isolated forest demands more than just physical endurance. It requires a calculated blend of raw natural resources and transported materials. Before the heavy labor begins, the early morning hours provide a necessary moment of rest. Operating far off the grid means every calorie of energy must be carefully managed. Transforming raw earth into a stable foundation requires specialized soil amendments. The builder introduces a commercially formulated agricultural and structural additive designed to improve moisture retention and bind loose particulate matter together. Pouring this damp, coarse mixture onto a waterproof tarp prevents the valuable compounds from leaching prematurely into the forest floor. This heavy, granular material will serve as a crucial binding agent when combined with standard masonry cement. In environments subject to heavy rain and fluctuating humidity, fortifying the base mixture is essential to prevent long-term settling and structural cracking. Moving hundreds of solid clay bricks up an uneven, densely vegetated slope is a grueling test of remote logistics. A standard metal wheelbarrow becomes the only viable transport method through the thick forest undergrowth, acting as a manual freight system. Navigating this unpredictable terrain demands careful weight distribution over the single tire. If the heavy load shifts over a hidden root or deep rut, the entire cart can easily capsize, spilling fragile masonry and wasting vital daytime energy. Organizing a remote worksite requires establishing distinct staging areas before any construction begins. Stacks of high-density red clay bricks are arranged close to the future footprint, while bags of Portland cement are kept elevated to prevent moisture absorption from the damp earth. The freshly mixed structural soil rests nearby on the tarp, ready for immediate use. In this isolated clearing, the builder is a temporary guest in a thriving ecosystem. Even the smallest native insects continue their endless foraging paths across the cleared dirt, completely indifferent to the massive geometric structure about to rise in their territory. Every material brought into this space must be carefully protected from sudden weather shift. By mid-morning, creating a reliable mortar base without mechanical equipment relies entirely on methodical manual labor. The builder uses a standard steel shovel to repeatedly turn the dry cement and modified soil together, ensuring an absolutely even distribution of binding agents before any water is introduced. Achieving a perfectly homogeneous dry mix is critical. It prevents hidden weak spots and structural cracking in the final cured foundation. This slow, repetitive folding motion is the hidden, energy-intensive core of all remote masonry work. Precision at the absolute earliest stage dictates the long-term success of the entire structure. Using a sharpened machete and a heavy trowel, the builder fashions temporary wooden stakes to anchor a tightly pulled string line. This simple tensioned wire acts as a flawless geometric guide, ensuring the foundational trench remains perfectly straight across the naturally uneven forest floor. Even a slight deviation in this initial layout would multiply into massive structural alignment failures by the time the heavy brick walls reach their final peak height. Water immediately activates the complex chemical curing process of the Portland cement, rapidly transforming the loose aggregate into a rigid, rock-like paste. Working the heavy, wet mixture requires constant turning, as the cement compound begins to undergo an exothermic hardening reaction almost immediately upon hydration. Shuttling this dense, saturated mortar via wheelbarrow across the scattered bricks is physically taxing, but absolutely necessary. Keeping the material continuously moving prevents it from stiffening and becoming useless before it can be laid into the foundational trench. The very first layer of masonry acts as the critical anchor point for the entire structural load of the shelter. A broad metal trowel compresses the thick wet cement bed, intentionally forcing out hidden air pockets that could compromise the foundation's load-bearing strength over time. The initial fired clay brick is pressed firmly down into the mortar, strictly aligned parallel to the tensioned string guide. These traditional red clay bricks are highly porous by design, naturally absorbing moisture from the wet cement to create a deeply fused, permanent chemical bond as both materials cure together. Tapping the side of the brick with the heavy trowel helps settle it into a perfectly level plane, setting the standard for the thousands of bricks that will soon follow. Hours later, as the brickwork steadily ascends, the physical and logistical demands of the build increase dramatically. The craftsman must now balance directly upon the partially cured lower walls to reach the new working height, placing absolute trust in the structural integrity of his earlier masonry. Every new horizontal course requires manually lifting dense wet mortar and heavy clay blocks further against gravity. The secret to stable vertical masonry lies in strictly staggering the vertical joints between each successive layer. Overlapping the bricks ensures that immense compressive forces from the eventual roof load will be distributed evenly downward and outward across the entire broad face of the wall. If vertical seams were allowed to stack directly on top of one another, the rigid wall would easily crack and collapse outward under its own immense weight. The constant, careful application of fresh gray cement fills any remaining hollow voids, locking the geometric grid together into a solid monolithic shell. Maintaining an absolutely consistent mortar moisture level is vital at this elevated stage. If the mix is too dry, it refuses to adhere to the porous clay. If it is too wet, the heavy weight of the upper bricks will squeeze the paste out, causing the rising wall to slump and permanently lose its plumb vertical alignment. The slow, rhythmic repetition of spreading mortar, setting the block, and scraping the excess becomes a quiet meditation in mechanical physics. Structural pillars demand an even higher degree of precision than standard continuous walls. Because they stand isolated and must support concentrated, localized loads from the upcoming roof beams, their internal masonry bonds must be flawless. The builder carefully uses the steel trowel to pack thick gray mortar onto the top surface of the freestanding columns, ensuring total coverage across the exposed brick chambers. Leaving any internal voids within a load-bearing pillar creates dangerous points of weakness where compressive failure usually begins. The damp, humid environment of the surrounding forest actually aids in this crucial curing phase. Concrete and mortar achieve their maximum theoretical strength when they dry slowly. The ambient moisture in the jungle air prevents the chemical hydration process from flashing off too quickly, significantly reducing the risk of microscopic shrinkage cracks. Periodically retreating to the wheelbarrow allows the craftsman to keep the dense mixture agitated and workable. Building isolated columns requires constantly checking for plumb verticality, as even a minor lean will be drastically magnified once the heavy timber roof structure is mounted across the gap. Capping the uppermost layer of the wall requires creating a perfectly smooth, level-bearing surface for the eventual roof framing. A final tension string line provides an unwavering reference point above the rough masonry. The trowel is used to glide a thick, unbroken layer of mortar across the brick tops, sealing the porous interior chambers from future water intrusion and providing a flat plateau for the timber beams. Transitioning from heavy masonry to structural framing requires a complete shift in both mindset and materials. The damp, heavy work of mixing cement is temporarily replaced by the sharp, precise mechanics of carpentry. Reaching into a protective plastic bag, the builder prepares a massive cache of long, heavy-gauge steel nails. In humid, tropical environments, metal fasteners are highly susceptible to rapid oxidation and rust, so they are kept sealed until the exact moment of use. These specific fasteners are engineered for serious structural shear strength, designed to bite deep into the dense fibers of natural timber and bamboo without bending or snapping under extreme lateral pressure. Unlike screws, which can easily shear off when structural wood naturally swells and twists with changing weather, thick steel nails possess enough ductility to flex slightly inside the joint while maintaining their incredible holding power. Preparing the hardware in advance prevents wasted movement. Once the heavy, awkward wooden beams are hoisted high up onto the newly leveled brick walls, the upcoming roof framing will completely rely on the friction and mechanical lock provided by these simple metal spikes. Reaching the absolute peak of the masonry walls requires elevated access and incredibly careful material management. The builder constructs a temporary wooden scaffolding plank, providing a stable, level working platform high above the uneven forest floor. Working at this final elevation means every single heavy brick and dense trowel of wet mortar must be manually hoisted up against gravity before it can be set. The detailed view reveals the highly specialized multi-chambered internal structure of these modern red clay blocks. Rather than being entirely solid, the hollow extruded vertical cores serve several vital mechanical and thermal functions. First, they drastically reduce the overall dead weight of the finished masonry wall, significantly lowering the long-term compressive stress on the dirt foundation below. More importantly, the trapped pockets of dead air within the hollow clay chambers act as a highly effective thermal break, naturally insulating the interior of the shelter from the intense, radiant heat of the jungle sun. When fresh mortar is spread thickly across these blocks, a portion of the wet cement is intentionally squeezed down into the open hollow voids. Once fully cured, these internal mortar plugs act like thousands of tiny, hidden concrete dowels, interlocking the courses together and massively increasing the wall's resistance to lateral wind shear. Setting these final top courses forms the ultimate parapet of the permanent structure, permanently dictating the exact pitch and drainage angle for the heavy roof to come. It is an exhausting balancing act of gravity and geometry. sourcing structural timber directly from the surrounding ecosystem requires a keen understanding of natural material property. The builder ventures deep into the humid undergrowth to harvest mature stands of green bamboo. Unlike traditional hardwood trees, bamboo is actually a giant, highly evolved species of grass, characterized by its hollow, segmented culms. Its incredible strength-to-weight ratio makes it one of the most efficient natural building materials on the planet. The solid nodes that punctuate the hollow stalks act as internal bulkheads, preventing the long poles from buckling or crushing under heavy compressive loads. Harvesting must be selective. Choosing older, fully hardened stalks ensures maximum structural rigidity and minimizes the risk of the bamboo shrinking or splitting as it eventually dries out in the sun. Dragging these massive, unwieldy poles through the dense, tangled carpet of ferns is a battle against friction and the claustrophobic geography of the forest. The surrounding decay, evident in the hollowed-out, rotting tree trunks, serves as a stark reminder of the jungle's relentless moisture. Any organic material left untreated on the dark, damp forest floor will quickly be reclaimed by fungus and rot. By elevating the harvested bamboo onto the dry, solid brick walls, the builder will isolate the timber from ground moisture, drastically extending the lifespan of the roof frame. The forest canopy above provides a chaotic, sprawling blueprint of natural engineering, a wild contrast to the strict, plumb geometry of the masonry shelter waiting back in the clearing. Establishing a heavy-duty timber roof frame begins far below the surface of the earth. The builder manually excavates deep, perfectly cylindrical post holes directly into the dense, root-tangled forest soil. The sheer depth of these foundational holes is structurally critical, burying a significant vertical portion of the timber utilizes the immense lateral pressure of the surrounding compacted earth to prevent the tall posts from leaning or swaying under heavy dynamic wind loads. Placing the raw, heavy wooden logs upright into the dark, narrow cavities transforms them from simply felled trees into incredibly rigid, load-bearing exterior columns. These primary vertical supports will eventually carry the immense cumulative dead weight of the entire overarching roof structure, transferring those massive compressive forces safely down into the stable subsoil below. Leaving the rough, natural bark intact on these thick columns provides a rugged first line of defense against boring insects and the relentless ambient humidity. nature continues its quiet observation as the heavy construction progresses. A flat, precision crosscut at the top of the wooden column is essential for providing a perfectly level-bearing surface where the massive horizontal roof beams will eventually rest. An uneven cut would create a dangerous point load, concentrating thousands of pounds of pressure onto a tiny sliver of wood, risking severe splitting over time. Using a heavy steel hammer, the builder drives thick galvanized nails deep into the timber to secure cross-bracing. The sudden, violent percussive force required to sink metal into dense, unseasoned wood echoes loudly through the silent, overgrown landscape. Driving nails into raw, green timber is actually highly advantageous, as the moist wood fibers eventually dry and shrink over the coming months. They will tightly constrict around the buried steel shank, creating a vice-like mechanical grip that is nearly impossible to pull apart. The vertical posts now stand as silent sentinels beside the brickwork. Bridging the wide open span across the parallel masonry walls requires manually hoisting massive, solid wooden beams high into the humid air. These primary horizontal lintels act as the foundational structural spine of the entire roof assembly, resting the incredibly heavy timber directly atop the rough, fully cured brickwork immediately ties the two completely distinct structural systems together. Because this remote region is highly prone to severe weather and sudden thermal updrafts, simply resting the beams on the masonry relies far too heavily on gravity alone. To combat dangerous aerodynamic uplift forces, the builder tightly wraps thick, highly pliable steel wire around the heavy timber, anchoring it deeply and securely into the rigid brick foundation below. This heavy-gauge steel wire binding functions as a flexible but essentially unbreakable mechanical tendon, guaranteeing the massive roof structure cannot be unexpectedly torn from the walls during a violent storm. Sitting precariously astride the high brick parapet, the builder carefully manipulates the long wooden span to ensure it remains perfectly parallel to the forest floor below. Any slight twist, sag, or structural warp in this primary horizontal beam would immediately telegraph upward, completely distorting the complex geometric layout of the bamboo rafters that will soon follow. The sheer physical height of the wall adds a constant, underlying layer of calculated risk to every heavy movement. Transforming raw, freshly harvested bamboo into a precision, load-bearing roofing grid demands exact measurements and highly specialized hand-cutting techniques. The builder relies entirely on a sharp, fine-toothed hand saw to cleanly slice through the incredibly dense, silica-rich outer fibers of the green bamboo stalks. Attempting to use a standard coarse wood blade would violently tear and splinter the rigid, tensioned outer wall, instantly compromising the stalk's incredible natural longitudinal strength. Fine wood shavings and pale, powdery sawdust accumulate rapidly on the forest floor as dozens of identical, lightweight rafters are systematically sized to fit the shelter's specific geometric roof pitch. following the precise horizontal crosscuts. A heavy, carbon steel machete is aggressively wielded to chop deep-angled notches and deliberately split certain thick poles straight down their center axis. Splitting a long, hollow bamboo culm perfectly in half creates an instantly flawless, naturally watertight drainage channel. These long-halved sections are ingeniously repurposed as highly efficient structural rain gutters and interlocking primary roofing tiles. This technique beautifully capitalizes on the plant's naturally smooth, hydrophobic inner lining to rapidly shed heavy, destructive monsoon water safely away from the vulnerable brick and dirt foundation. The sharp, rhythmic, percussive sound of the heavy machete striking the resonant hollow wood rings out over the steady ambient background drone of running water from a nearby utility pipe. Every individual piece of rigid bamboo must be carefully custom-fitted and manually carved to perfectly match the irregular, organic curves of the massive primary wooden support beams. It is a slow, deeply exhausting process of physical subtractive manufacturing, slowly turning a chaotic pile of raw jungle brush into a highly organized, tightly integrated architectural canopy. By the next morning, with the rigid, interlocking skeletal frame finally complete, the open structure urgently requires a waterproof exterior skin. The builder systematically gathers massive, heavy quantities of broad, freshly cut green palm leaves, kneeling on the damp forest earth to manually compress the wild foliage into dense, highly organized bundles. Wrapping heavy galvanized steel wire tightly around the thick, rigid fibrous stems prevents the slippery, waxy leaves from separating or violently sliding apart. During the difficult, unbalanced transport up to the high roof line, freshly harvested palm leaves are incredibly heavy due to their massive internal water content, making the repeated vertical journey up the wooden scaffolding an exhausting, relentless test of brute physical stamina. However, utilizing these green, highly flexible fronds is absolutely crucial for creating a permanently sealed, weather-tight roof assembly. If the wide leaves were allowed to dry out and become stiff and brittle on the ground beforehand, they would easily crack and shatter when folded tightly over the sharp bamboo rafters, resulting in disastrous, unpatchable structural leaks. By hoisting the dense bundles upward while the cellular structure of the thick leaf is still plump, saturated, and highly pliable, the craftsman ensures the organic material will naturally drape, tightly conform, and overlap seamlessly across the complex, sloping geometry of the wooden grid. working precariously high above the ground, the builder begins the incredibly meticulous, highly repetitive, overlapping process of traditional palm leaf thatching. Each individual broad, green frond must be carefully positioned, aggressively flattened, and pressed firmly against the underlying rigid bamboo grid. The ancient waterproofing technique relies entirely on gravity, aggressive overlap, and dramatic material density. By stacking the wide, waxy leaves like massive, organic exterior shingles, heavy rainwater is mechanically forced to continuously cascade downward from one slick surface to the next, entirely bypassing the vulnerable, dry wooden rafters hidden directly beneath. Securing the thick thatch, starting from the lowest bottom edge of the roofline and slowly working upward toward the absolute peak, is a strict rule. It ensures that the wide lower edge of every new leaf completely covers and protects the vulnerable tied stem of the leaf positioned immediately below it. If this strict, bottom-up overlapping sequence were somehow reversed or sloppily misaligned, heavy rainwater would instantly channel backward into the exposed seams, heavily flooding the interior of the newly built masonry room. Beyond incredible waterproofing, the dense, multi-layered mat of fresh jungle vegetation also provides an exceptional, highly efficient thermal barrier. The thick pockets of naturally trapped air and the sheer, saturated mass of the green leaves will aggressively block the intense radiant heat of the direct midday sun. Sealing the absolute peak of the roof is the most critical and difficult phase of the entire thatching process, because the structural apex is completely exposed to the harshest vertical rain and tearing wind gusts. The final overlying layers of palm leaves must be violently compressed and bound securely with tight loops of metal wire. If the crown of the roof were to lift or blow away during a severe storm, the entire underlying masonry structure would be rapidly compromised by cascading interior water damage. Stepping back from the massive completed canopy allows the builder to critically visually inspect the sweeping continuous lines of the deep green thatch. A properly executed palm roof should exhibit a completely smooth, unbroken, heavily armored surface, with no obvious gaps or irregular depressions where standing water could pool and cause premature rot. The sharp, vibrant yellow pumpkin flowers, blooming quietly near the muddy base of the construction site, offer a vivid, momentary contrast to the heavy, muted earth tones of the newly erected shelter. The completed roof radically transforms the psychological feeling of the space. It is no longer just an open, vulnerable arrangement of stacked bricks and raw timber. It is now a fully enclosed, permanently shielded sanctuary, deeply integrated into the sprawling, overcast forest landscape. With the structure completely sealed from the unpredictable weather above, attention finally turns inward to the raw, uneven dirt floor. A clean, durable interior surface requires a completely different mortar ratio than the heavy structural mix used for the exterior load-bearing walls. The builder drags a heavy, industrial paper sack of fine Portland cement across a massive pile of dark, moisture-rich river sand. Using the broad steel shovel, he aggressively chops and folds the dry powder directly into the damp aggregate. Combining the materials on the ground before adding supplementary water prevents the ultrafine cement dust from simply washing away or forming useless, dry, unmixed clods. Transferring the incredibly heavy, fully saturated gray sludge into the deep metal wheelbarrow is backbreaking, highly repetitive labor. The thick, clumpy consistency of the wet mixture is highly intentional. A floor screed needs to be relatively stiff so it can be aggressively packed and leveled with heavy pressure rather than flowing unpredictably like a thin, watery liquid. Transforming the chaotic, heavy, lumpy piles of wet mortar into a perfectly flat, highly functional interior architectural surface requires rapid, sustained mechanical action. The builder uses a brightly colored, flat-bladed steel trowel to aggressively smear, pack, and compress the dense gray paste directly over the raw, naturally uneven earth. A long, incredibly rigid metal straightedge is then violently dragged back and forth across the wide, wet expanse. This aggressive, side-to-side sawing motion, technically known as screeding, cleanly shears off any localized high spots and forcibly pushes the displaced wet cement deep into any underlying low depressions in the dirt base. Because the relatively thin mortar layer begins to chemically hydrate, rapidly heat up, and permanently harden within minutes of being spread across the dry ground, the physical leveling process must be executed quickly, seamlessly, and without any hesitation before the material locks into place. Finishing the delicate transition edge near the main doorway demands highly concentrated, intricate trowel work. This specific high-traffic threshold will eventually bear the brunt of heavy, repeated daily footfalls, making a dense, perfectly compressed cement edge an absolute structural necessity. The smooth, flat, sweeping gray expanse of the newly finished floor immediately creates a stark, highly refined visual contrast against the chaotic, violently rough-textured red clay masonry of the surrounding walls. Leaving the heavy wheelbarrow parked directly outside the entrance keeps the rapidly stiffening mortar supply within easy, immediate reach. The builder must continuously float the flat steel trowel over the curing surface, using light, sweeping circular pressure to carefully draw the fine moisture and microscopic cement particles to the absolute top. This specialized finishing technique, known as polishing the slab, effectively seals the porous concrete, creating a much harder, highly dust-resistant, and easily sweepable interior surface. Dividing the exterior space requires laying a secondary, highly precise foundational footprint. a stark white tensioned string line is stretched low and violently taut across the loose dirt, establishing a flawless, unbending geometric plane. Even the slightest miscalculation in this initial layout would cause the massive new brick boundary to run disastrously crooked. A shallow trench is aggressively carved out of the compacted soil directly beneath the guide wire, exposing a clean, solid, and completely undisturbed earth base. The heavy, dark gray structural mortar is laid thickly into the excavated channel, creating a highly adhesive, leveling bed for the raw red masonry. Pressing the first heavy, porous clay bricks firmly down into the wet sludge instantly begins the complex chemical bonding process, sinking this initial foundational row entirely below the natural grade of the surrounding yard ensures the massive heavy wall will never shift, slide, or blow out under intense lateral ground pressure. Integrating raw, organic timber framing directly into rigid masonry requires specialized chemical anchoring techniques. The builder uses the trowel to heavily pack wet, dense cement tightly around the vulnerable buried base of a vertical wooden post. This thick mortar collar not only locks the heavy timber permanently into a plumb, unmoving upright position, but it also creates a highly effective, impenetrable physical barrier against destructive subterranean moisture and aggressive wood-boring insects. The continuous row of heavy red clay bricks progresses steadily along the excavated trench, held tightly together by the thick, deeply colored gray mortar joints. Because the natural ground is inherently sloping and uneven, this crucial, buried foundation layer absorbs all the radical, topographic variations. By deliberately manipulating the varying thickness of the wet mortar bed beneath each individual brick, the builder successfully creates a perfectly level, totally flat masonry plateau, ready to support the massive vertical weight of the rising walls above. Finalizing the exterior hardscape requires moving massive volumes of heavy, wet material with brutal, relentless efficiency. The heavy steel shovel acts as both a bulk transport mechanism and a crude, effective leveling blade, aggressively pressing the thick, dark mortar down into the loose, unstable dirt. A solid, perfectly flat exterior apron is absolutely vital. It permanently directs highly destructive, cascading rainwater safely away from the vulnerable, newly laid brick foundation trenches. Crouching low to the wet ground, the builder utilizes a small, rigid metal trowel and a long, straight aluminum level to meticulously shear off any lingering high spots. Scraping the heavy metal edge violently across the rapidly stiffening cement physically forces the larger, bulky sand aggregates downward, allowing only the ultra-fine, highly workable cement paste to rise to the smooth surface. A massive, naturally flat riverstone is intentionally left deeply embedded within the fresh concrete pour. This is not merely an aesthetic, decorative choice. Leaving massive, solid boulders fully integrated into the thin slab drastically reduces the total volume of expensive, imported cement required, while simultaneously acting as a massive, immovable mechanical anchor, permanently locking the brittle, floating mortar floor directly into the solid earth below. A highly productive, safe construction site demands constant, methodical organization. As the massive masonry phases finally conclude, the builder painstakingly gathers the scattered, leftover red clay blocks, stacking them neatly and securely along the raised perimeter of the newly cured foundation. Leaving heavy, jagged debris strewn chaotically across the active workspace creates an incredibly dangerous trip hazard, especially when carrying sharp, heavy carpentry tools. Pushing the heavy, steel wheelbarrow through the tall, uncut grass, the builder violently shovels away the accumulated, useless mounds of excavated dirt and dried, wasted mortar, clearing away this suffocating layer of industrial refuse. Finally allows the sprawling, delicate natural beauty of the surrounding forest to gently reclaim the absolute edges of the rigid, geometric architecture. Transitioning from massive bricklaying to the fine, highly detailed interior carpentry requires a delicate, almost surgical approach to handling raw, natural materials. Crouching entirely within the deeply shaded, heavily insulated interior of the brick structure, the builder carefully begins assembling the customized, rigid bamboo window frame. Because the heavy masonry wall opening was built entirely by hand. Without a laser level, it naturally possesses subtle, unavoidable dimensional irregularities that a perfectly square, mass-produced factory window could never easily accommodate. Therefore, every single piece of lightweight, hollow green bamboo must be individually measured, painstakingly hand-cut, and precisely friction-fitted directly against the rough, highly abrasive red clay walls. The intricate, deep angular notches carved deeply into the ends of the green stalks allow the round, normally slippery poles to physically interlock perfectly at precise right angles. This forms a highly rigid, unbending rectangular skeleton without the immediate need for driving heavy metal fasteners. Leaving large, completely unglazed window openings is a deliberate, highly functional architectural strategy in this sweltering, incredibly humid, tropical environment. The massive, open apertures will aggressively capture and funnel prevailing cooling breezes directly through the tight interior space, naturally ventilating the heavy masonry room. Fleshing out the empty window frame requires weaving a protective, highly functional barrier. The builder carefully attaches long, remarkably thin, vertically split bamboo slats horizontally across the heavier vertical structural posts. Creating this dense, tightly spaced geometric grid serves a crucial dual purpose. Physically, it operates as a highly resilient, impenetrable security screen, effectively blocking large, opportunistic wildlife and dangerous, wind-blown forest debris from violently entering the vulnerable living space during a sudden, severe tropical storm. Environmentally, the tightly spaced, horizontal wooden louvers drastically filter and shatter the intense, blinding glare of the direct afternoon sun, casting a soft, deeply textured, and heavily fractured ambient light directly across the smooth, cool, newly cured cement floor. The meticulous, highly repetitive process of measuring, cutting, and tightly lashing each individual thin wooden slat slowly transforms the massive, empty brick void into a beautiful, highly refined architectural focal point. Installing a lightweight, highly flexible organic frame directly into a rigid, completely unforgiving masonry opening requires absolute precision and heavy mechanical anchoring. The builder slowly hoists the completely assembled, complex bamboo grid directly into the massive brick void. He uses his own physical body weight to violently press, wedge, and jam the tight wooden joints flat against the rough, highly abrasive clay interior walls. To permanently lock the lightweight slatted screen in place, he tightly twists heavy gauge, galvanized steel wire entirely around the thick outer bamboo perimeter, anchoring it deeply and securely into the heavy structural masonry mortar joints hidden directly behind it. This highly tensioned, invisible metal wire binding guarantees the lightweight wooden window cannot be easily sucked outward or violently blown inward by the massive, invisible aerodynamic pressure differentials rapidly created during a severe, high-speed jungle storm. Constructing a massive, solid, heavy-duty wooden door entirely from scratch requires completely transforming rough, deeply uneven, raw lumber into perfectly square, tightly fitting geometric planks. Kneeling directly on the hard, newly cured gray concrete floor, the builder uses a highly sharpened, fine-toothed steel handsaw to violently crosscut the incredibly thick, deeply grained wooden boards. Operating a simple manual hand saw with this level of incredible, flawless precision requires a deeply ingrained, highly rhythmic physical motion. The craftsman must patiently allow the sharp, hardened steel teeth to aggressively do the actual cutting work, rather than foolishly trying to physically force, twist, or violently bend the fragile metal blades directly through the dense, unyielding wood fibers. The rapid, messy accumulation of fine, powdery sawdust across the clean interior floor acts as a vivid, highly visible physical testament to the sheer caloric energy being violently expended to sever the dense, hardened cellulose. Achieving a perfectly straight, flawlessly clean, 90-degree angular cut is absolutely structurally essential here. If the heavy, incredibly thick wooden planks are sawn even slightly out of square or badly misaligned, the final, massive assembled door will violently warp, terribly bind, and ultimately fail to swing shut smoothly within the tight, unyielding masonry frame. Fusing dozens of individual, completely isolated wooden planks into a single, massive, unbending solid physical barrier requires heavy mechanical bracing and absolute geometric alignment. Working entirely flat on the rigid, perfectly level interior concrete floor, the builder tightly clamps the heavy, thick boards flush against one another, violently driving long, heavy-duty steel fasteners deep into the intersecting horizontal cross braces. These incredibly thick, horizontal wooden batten cleats act as the absolutely critical, unyielding structural spine of the heavy door. They actively prevent the massive parallel vertical planks from naturally twisting, dangerously sagging out of square, or violently pulling completely apart as the raw, porous wood inevitably shrinks and wildly expands with the extreme, constantly shifting jungle humidity. The sudden, stark introduction of highly machined, mass-produced metal hardware. Shiny, factory-stamped steel hinges and sharply threaded metal screws marks a massive, highly significant technological shift from the purely raw, incredibly organic, chaotic, and natural materials utilized so heavily throughout the earlier, vastly more primitive construction phases of the massive shelter. Hanging a massive, incredibly heavy, solid timber door is a deeply exhausting, highly precise balancing act that fights directly against the relentless downward pull of gravity. The builder must physically wedge the massive, unwieldy wooden assembly tightly into the rigid, unyielding brick frame, temporarily suspending hundreds of pounds of dead weight solely with his own exhausted muscles. With one hand violently straining to keep the massive door perfectly plumb and level, he rapidly uses a sharp metal screwdriver to tightly sink the thick, threaded steel screws directly through the heavy metal hinge plates and deep into the dense, unforgiving structural wood framing. Using a heavy steel hammer to violently drive supplementary, thick metal nails directly into the heavy hinge assembly provides an absolutely crucial secondary layer of immense mechanical shear strength. If the heavy metal hinges were secured weakly, the massive, repeated, violent, swinging momentum of the incredibly heavy solid wood door would quickly rip the short screws entirely out of the frame. Installing a heavy, sliding steel locking bolt provides the final, crucial element of absolute, impenetrable physical security for the newly enclosed architectural sanctuary, driving the final, incredibly thick metal nails deeply into the heavy steel lock assembly permanently and irreversibly, marries the complex, moving mechanical hardware directly to the solid, unyielding organic timber. Stepping far outside into the lush, overgrown green clearing, the massive, fully functional wooden door completely seals the large, gaping architectural void. This simple mechanical action instantly transforms the dark, open, highly vulnerable brick cave into a completely secure, highly fortified, permanently enclosed personal fortress against the wild jungle. Bending down to exhaustingly gather the scattered, chaotic piles of leftover, jagged scrap wood and dangerous, discarded sharp debris signifies the absolute, final, undeniable end of the heavy, highly destructive, violently chaotic construction phase. The massive permanent structure is finally, completely, and beautifully, fully realized in the forest. Sweeping the fine, powdery sawdust from the perfectly smooth, cool interior concrete floor is the final, deeply quiet ritual of architectural completion. The violent, deafening chaos of heavy excavation, relentless wet masonry, and aggressive, loud timber framing has entirely faded, replaced completely by the profound, absolute silence of the deep surrounding forest. What began weeks ago as merely a raw, muddy, chaotic scar in the dense jungle undergrowth is now a permanent, highly fortified, fully functioning shelter. In the end, structure, landscape, and daily routine operate as one system. A place that produces, protects, and sustains itself.